Welcome to AI Podcast. Today we are digging into WebAgent R1, a new EMNLP 2025 paper on training web agents with end-to-end multi-turn reinforcement learning.
Sounds timely. Give me the quick headline first. What is the big idea in plain English?
The authors show that you can take a language model, drop it into a realistic browser environment, and let it learn by doing across many steps. With a simple yes or no reward, the agent gets noticeably better at completing real web tasks compared to standard prompting or imitation alone.
So it actually clicks around and learns from the outcome, not just from examples.
Exactly. Think of it as learning to drive by actually driving instead of only watching dashcam videos.
Who is behind it?
The work is led by Zhepei Wei with colleagues at Amazon and the University of Virginia, and folks like Li-Hong Li are on the paper as well.
Nice. Set the stage for me. What makes the web such a tough arena for these agents?
The web is messy and long horizon. Pages change, logins pop up, menus shift, and a task like file an issue or compare products takes many small actions. Past systems leaned on prompting or behavior cloning from demonstrations, which is like memorizing a few routes. It helps, but when the road changes, you get lost.
Right, and I have seen off-policy reinforcement learning in other papers too. Why was that not enough?
Off-policy methods learn from a replay buffer of past trajectories, which can drift away from what the current agent would actually do. You also need extra infrastructure like data filters and learned reward models. This paper bets on policy learning, which keeps the data and the policy in lockstep and keeps the pipeline simpler. No learned reward model, just rule-based checks.
On policy, as in the agent collects fresh experiences with its current brain, then updates from those.
Exactly, and they extend a technique called group relative policy optimization to the multi-turn setting. Picture a classroom where students are graded relative to how their small group did on the same assignment. The agent compares its own trajectories within a recent batch, so it gets a stable signal without a heavy critic network.
I like that curve grading analogy. What about this context problem you mentioned? These agents read a lot of HTML and text. That can get long fast.
It does. Their fix is dynamic context compression. Imagine packing a suitcase for a long trip. As the journey goes on, you roll the socks and toss the brochures you no longer need. The agent keeps the critical state, like form fields or key snippets, and collapses the rest so the model stays within its context window.
And how do they speed up learning? Browsers can be slow?
They spin up many independent browsers in parallel with separate cookies. Think of a room full of interns all trying the same task at once. That gives diverse attempts quickly.
You mentioned simple rewards. How simple are we talking?
Binary. After a trajectory, a rule checks things like whether the final page matches the target URL or whether the required text is present. Green check or red X. No separate reward model to train.
All right, where did they evaluate this?
On WebArena Lite, which is a realistic, self-hosted suite of sites, it includes things like a forum, a code hosting service, a content management system, maps, and shopping. The tasks are human-written and verified.
And they fine-tuned open models, right?
Yes, smaller open backbones like Quen and Llama. They first warm start with behavior cloning on demonstrations so the agent knows basic web hygiene, then switch to on-policy reinforcement learning to explore and refine.
How much did it help in practice?
By a lot. For the smaller model, the success rate climbs from roughly 20% with imitation to the mid-30s with WebAgent R1. For the larger one, it reaches the mid-40s. On that benchmark, it also edges out at least one strong proprietary reasoning model.
That is impressive for a fairly lean setup. Did they check why it works?
They ran ablations, starting reinforcement learning from scratch with no imitation, sputters. The agent just does not have the basic skills to explore productively. If you pre-train with long chain of thought traces, you get a better starting point. But the later exploration gains can be smaller, maybe because the model sticks to a verbose routine. They also show that adding a think then answer style prompt boosts engagement, and simply letting the agent take a few more steps at test time gives a steady bump.
So 2 practical tips for anyone building web agents. Encourage structured thinking in the prompt, and do not be stingy with the step budget.
Exactly.
What about learning dynamics? Anything interesting there?
You see three phases. First, skill acquisition, where rewards rise and trajectories get longer. Then exploration and refinement, a bit of a plateau as the agent tries new paths and trims wasted clicks. Finally, stabilization, where performance creeps up and interaction counts settle.
Did they try outside the main benchmark?
Yes, on a separate suite called Web Voyager. Without extra training, the WebAgent R1 policy outperforms simple prompting and plain supervised fine-tuning across several domains. That suggests the learned strategies are not purely benchmark specific.
I have to ask about caveats. What keeps you cautious here?
A few things. Web Arena Lite is realistic, but still controlled and rule-checked. Real sites have logins, CAPTCHAs, and unpredictable layout changes. The reward story is elegant, but those yes or no checks do not exist for many open-ended tasks like trip planning. The agent reads text only, no screenshots, so layout cues are missing. The action set is fixed, which can limit adaptation to novel widgets. And training requires a farm of browsers and careful environment setup, though the authors do release code to help with reproducibility.
Safety too, right? A web agent poking at real sites can do damage.
Absolutely. The paper encourages permissioning and verification prompts, which is sensible. In deployment, you would want reversible actions and human-in-the-loop checks for anything destructive.
If I am an engineer choosing a path forward, when would I pick this recipe?
If your tasks admit a clear success check, even a simple one, and you can run parallel browsing on policy reinforcement learning like this is compelling. It keeps the system end-to-end, avoids an extra reward model, and it clearly moves the needle. Start with a good behavior cloning warm start, add a think then answer prompt, and give the agent enough steps to work.
And future work you would love to see.
Bring in vision so the agent can see what the page looks like, not just its HTML. Explore lightweight preference rewards when rules are not available. Let the agent expand its toolset safely. And of course, test on partially uncontrolled live sites to measure robustness over time.
Got it. Quick recap for listeners. WebAgent R1 shows that a straightforward on-policy approach with group relative optimization, context compression, parallel rollouts, and simple binary rewards can lift web agent success on realistic tasks. It is not the final word, but it is a clean, practical blueprint.
Well put. If you care about agents that actually get things done online, this is a paper worth reading and a recipe worth trying.
That wraps it for today on AI Podcast. Thanks for listening.
See you reuse next time.